From the invisible twist of a magnetic field to the cloak of an electron sea, this collection transforms abstract spatial logic into the visible architecture of the physical universe. The alphabet of space and measurement. The journey begins by establishing the fundamental rules for how objects interact in three-dimensional space. By defining the logic gates of rotation and direction, these derivation sheets prove that simple geometric shapes hold deep mathematical secrets. For instance, a four-sided shape only has perfectly perpendicular diagonals if all its sides are equal, and the internal angles of a cube's diagonals remain eternally constant regardless of whether the cube is the size of an atom or a galaxy. Crucially, these derivation sheets reveal that to truly measure space, one must use two different measuring sticks. One set of vectors to build a path, the tangent basis, and a reciprocal set to probe its hidden components, the dual basis. This dual perspective allows scientists to navigate non-orthogonal environments where standard rectangular grids fail. The personality of fields. Outflow and swirl. Once the rules of space are set, the narrative shifts to the texture of physical fields, the invisible forces like gravity and electricity that fill our world. These fields are described by two primary personalities: outward flow from a source, divergence, and internal rotation around a point, curl. Through various proofs, these derivation sheets establish zero laws that act as physical constraints. For example, a field that only moves uphill, like a mountain slope, can never swirl back to its starting point without going downhill, a principle that forms the basis for energy conservation. These constraints culminate in a mathematical lock known as the Uniqueness theorem. If you know a field's internal sources, its rotation, and how it behaves at the boundaries, that field is frozen into a single possible state with no room for variation. Global laws from local observations. The collection bridges the gap between what happens at a single point and what happens across an entire volume. Using powerful integral theorems, these derivation sheets verify that the total mass or fluid flowing through a boundary must exactly match the amount being created or destroyed inside. This leads to the discovery of topological independence. For certain fields, the total twist or circulation around a loop depends only on the boundary itself, not on the specific shape of the surface capping that loop. However, if a field contains a hole or a singularity, like the magnetic field around a wire, the results become quantized, depending entirely on how many times a path wraps around that hidden center. Perspective and symmetry. Mapping reality. To simplify complex problems, these derivation sheets venture into specialized coordinate systems that match the symmetry of nature. Hyperbolic coordinates. These serve as the natural language for special relativity, where space and time warp together during high-speed travel. They also provide the foundation for long-range navigation, LORAN, and pinpointing the exact origin of a sound, such as sniper detection. Parabolic coordinates. These describe the focusing power used to design satellite dishes and searchlights, ensuring all incoming signals hit a single point in perfect phase. They are also the only way to solve for the shifting energy levels of an atom under an external electric field. Spherical and cylindrical bases. These ensure that robots can move precisely without unintended parasitic motions and allow physicists to solve the mystery of the hydrogen atom by separating the electron's radial shells from its angular lobes. Dynamics of helices and invisible forces. The narrative concludes by applying these rules to motion and electromagnetism. These derivation sheets track objects carving out helical, corkscrew paths, proving that even complex motion can have constant properties like a steady speed. They explore the butterfly patterns of magnetic dipoles, revealing that for these fields to be consistent, their lines must snap through the center to form complete, closed loops, as magnetic monopoles cannot exist. Finally, the project investigates the Yukawa potential, illustrating a cloaking effect in plasmas where a dense sea of electrons clusters around a central charge, systematically soaking up its flux and hiding it from the rest of the universe. Throughout this journey, these derivation sheets confirm the principle of zero work, proving that while magnetic fields can steer charged particles in spirals or circles, they can never change their speed or kinetic energy,